The next element is movement. I'm sorry, element, principle. The next principle is movement. So obviously, yes, we keep coming back to good old Van Gogh. There's no denying that in Van Gogh's eyes, he saw the heavens at night as a swirling, moving mass of starlight and almost cosmic gases, things that we wouldn't see until the Hubble Space Telescope was launched. So, we look at the night sky and we see the pinholes and stuff, but he was seeing movement, on a very clear night that most people would never recognize. So there's lots of movement, not just in the sky, but also too in the growth of this tree, how the marks are made moving upwards, the rolling, this little mark making of the rolling of the tops of these smaller trees off in the distance, the movement of the hills sweeping up. This is just 2D, 3D perceived as moving or in motion. Now, this is nobody famous. It's just a design I found online that really shows a lot of in and out tangles, almost tunnels. And there's a sense of three-dimensionality because of these contour lines that go around the shape instead of just straight lines coming through it to indicate that it has some sort of three-dimensional form to it. But all of this seems to be in motion, moving, intertwining, almost like a bed of snakes, which would terrify me. So this is an op art. Now, not to be confused with pop art, where you were taking popular culture and trying to elevate it to the art world. Op art was optical art. This was like that, the optical illusions you see online, but a lot of people in the early 60s started doing this optical art in the age prior to computer graphics, where they would just make these designs and patterns that would mess with people's eyes. And that was really the only goal, this illusion that movement in squares, like 2 pages of a book coming together in the gutter of their spine, as the squares get narrower and narrower and fold in. But it also creates a vibration to your eyes. So again, it's giving that illusion of movement. The one optical illusion I showed you in class when we were looking at elements, I had one student that couldn't even look at it because it just was weirding him out. Couldn't do it. Again, back with the Great Wave, not only we were talking about negative versus positive space and all that, but the sweeping movement, the linear, the line elements, the little curlicues on the ends of the wave showing you it's almost like talons of a bird of prey coming to crash on to these people on these boats. You could see them crouched down ready for the impact of the swirling tall wave. So it also has a lot of movement, not only done with line and shape, but also repetition. We have lots of rhythm in it, sweeping, moving lines, lots of flow, lots of movement, as you can see. Everything coming, crashing, swirling, all of them just sweeping this piece into a sense of movement. Now, even in sculpture, and this is a cubist sculpture, so much like nude descending a staircase, a still sculpture can still really indicate motion. These we see the legs, the person walking, unique forms of continuity in space is what it's called. That's just a big fancy name for, all these look like big giant billowy pants from Broadway, You see like almost the wind blowing against the clothing wrapped around this figure. Again, perceived movement. Back to this one. Okay, lots of motion, lots of repeated areas. Then you have people like Frederick Remington, the famous American Western artist, you know, is trying to show the action and excitement of life out on the range when there were still large cattle drives and there were actual real cowboys, not these guys you see at, you know, Colton's who wish they were wearing spurs. You know, the arc of the horse's body, the way the tail is swirling, and then that line continues up to this big arc, this arced body of this horse, its front legs so tucked in it becomes almost like, more like a dolphin than a horse, you know, leaping out of the water. And everything else is kind of just the same. And then he has his puffs of dust showing that these impacts have taken place. Okay, the tightening of the rope, the swirl of the loose ropes, the leather flying off the saddle, even the fuzzy chaps, those bearskin chaps, the momentary loss of gravity as they reach up as this leap happens, his hat falling off his head, all indicating movement. The Laocoon statue and his sons, ancient Greek and made out of marble, perceived movement. Now, when we talk about perceived movement, obviously paintings aren't in motion. Sculptures obviously are in motion most of the time. Only with things like animation or film do two-dimensional images begin to move. And then when we talk about kinetic sculpture, then actual sculptures begin to move. But in pieces like this, we see the writhing and the one son is pushing the snake's tail off of his ankle. The other son is reaching back, trying to stop. This one's biting him in the ribs. He's got his hand on it, but he's in the process of falling backwards, as is the father, who is pushing down, trying to fight this serpent off of him. And then, of course, this arm is broken off. But all of the movement and the struggle with these two giant serpents is really shown to be a lot of action happening, as if it was caught on camera in mid-fight. Now, actual movement in art, kinetic art, is, we've talked about it a little bit. We've looked at the kinetic rain, but we're going to look at some more kinetic art. Now, kinetic art, most of the time, is three-dimensional. Some kinetic art is somewhat two-dimensional. Obviously, you have multimedia, like projections and film and stuff like that, that is still two-dimensional. But with kinetic art, it can be run by motor. It can be the simple movement of a person by it, causing a slight breeze. Wind-powered, motor-powered. Sometimes it's only moving when it rains. Sometimes it only moves when the sun's out and it heats up the metal and then the metal shifts. So one of the guys who was kind of the king of this early form of kinetic art was a man by the name of Alexander Calder. And Calder created these giant mobiles that were sheet metal, steel, welded, balanced perfectly. Some were as big as half of a room, and some were even bigger. You can see here it's 110 inches by 230 inches by 180 inches. It's not small. And it takes very little wind or even someone blowing on just one of the panels to put it into motion. That's how perfectly balanced it is. So it is actually in movement. Now, George Ricci, he was another pioneer of kinetic art, and I have a video here because looking at photographs of moving art that's not moving is terrible. So this is some of George Ricci's kinetic sculptures, much like Calder, wind powered. You know, it's one of those almost like perpetual motion machines. A lot of clockmakers in the 1700s worked tirelessly to figure out balances and weights, and they would make automatons, little robots that would perform little tasks, but they were usually wound with a spring and they had clockwork in them and they would take off. Some of them were weighted, just like this one has its balance to a way, but each time these things tilt, it changes. So this one is perfectly balanced, but as it tilts back and forth, the little panels begin to spin. And the more they spin, the more they throw things off balance. So you could see it now is really starting to go. So each time this thing rocks, and each time those perfectly little balanced panels start to spin on their axis, it throws off the weight of the sculpture, making it constantly change in its appearance. It's constantly in movement. And it's not motorized or anything. It just took one little push and it was on its way. And again, dealing with springs and balances, and they just rock and put pressure against each other to make each other move. Now, they may not be your cup of tea in terms of like looking at them. Like me, these are not that pretty. The brushed metal and the welded corners, I'm like, whatever. This one doesn't really send me in terms of aesthetics, but the movement of it is really nice. That just looks like someone took Wolverine's claws off of him and turned a sculpture into it. So, and this goes on, you know, consistently, I think. Let's see. This one's kind of fun because it seems so top heavy, you know, but it's so thin at the top and the weight is so heavy, so it does tilt, but it can't stay tilted totally. So George Ricci was another one along with Alexander Calder. All right, and then this guy, Anthony Howe, he is more recent to the world of wind sculpture, wind art. And his stuff is really amazing because when you see how large it is extremely massive. And the patterns that he's designed are really hypnotic. Okay, here we go. Oh, come on. You can do it. Don't make me look bad in front of the PC kids, Mac. There we go. All right, so this guy's work, as you go down through it, you can see the size of it compared to a person. Hundreds and hundreds of layers that intertwine, but his pieces do get larger. I don't know if you could tell, but this one here, the one that was on the slide, is as tall as a tree. So these are close-ups of it in motion. But you can see here how the head is two of him, almost three, 2.5 of him. And then when it's put on its pedestal in its final home, And he deals a lot with organic animals, sea creatures. You know, this one's called Deocto, which, you know, referring to the movements of an octopus. But let's see if, I don't know if there's another picture of him standing by it once it's on its pedestal or not. Probably not. Let's see. Well, there's one of him standing next to it on its pedestal. So you can see how massive these structures are. And they're totally wind powered. Now, this gentleman, Theo Johnson, from, I believe he's from Denmark or Sweden, he creates these things called strand beasts. They are also wind-powered kinetic sculptures, but these guys walk, and they're quite terrifying. And how they're done is he basically creates a crankshaft, very much like in your car. I can't seem to find my mouse. Okay, so these strand beasts, now that I've got my mouse back, he creates them. They have basically a crankshaft in them, like a car, that motivates their legs, and when the wind takes them, or they get a little nudge, they take off across the beach. Let's see if I can find, he did some modeled ones out of cardboard as well. These are actually made out of wood. Let's see if he's got a video. Yeah, look at this thing. Now he has to kind of push it and move it. It's so heavy. But you can see all the hinges. You can see that there for a second, that crankshaft. You know, this one's really heavy. But if you move one, they all begin to move and walk. Let's see here. Let's close that. Let's see if I can find one that takes off running. Again, actual movement. One of the principles of design is movement. We looked at movement in terms of paintings, and now we're looking at actual sculptural movement. Which one was it that took off really fast? Perhaps, let's see. No, let's see. Perhaps it was this one. So it's got its sails on it, and he's getting ready to basically launch it. He gives it a little tug and then gets out of the way, and the wind makes it continue as long as it's giving it enough force. And there it goes, running across the beach. Kind of disturbing. If you saw that thing running at you, you might go the other direction. 11 feet by 4 feet by 4 feet. Now this one's made out of plastic tubing. He found something lighter and much more durable. So it's all made out of PVC pipe, basically. And then you could just stop it. Okay, and then the next and final kinetic sculpture. This is actually a former classmate of mine, Nemo Gould. He's headquartered out of San Francisco, and he has done lots of kinetic sculpture. Some are smaller, some are not. He does some two-dimensional things. He's very much into found objects, and these are almost all motorized. Some things like Case Study is simply almost a footlocker full of diodes and all kinds of things. If this is going to load or not, it doesn't seem like it's going to load. That's unfortunate. Let's see if his Petroparasite will load. The site seems to be having trouble. But I could find a YouTube video of it if I have to. Yeah, let me go to YouTube. This one's not playing for some reason. So I'll just type in his name. Okay, so let's see here. So Megalodon, which is from 2016, he actually used part of an old small airplane to create the body of the giant shark. The teeth are all made out of spoons. Now this one doesn't actually go anywhere. It sits still, but it does move. He animated the tail. But the fun part is actually on this other side with the opening, where you get to see the little robots working to make the Megalodon go. So it's almost a steampunk version of the inner workings of these little robot creatures he makes. This one actually is turning a valve. But he collects all these gears and diodes and gauges from old defunct factory machines. And, like this is an old air vent off of something that is now gills. And these spoons for the teeth. And you notice the old nuclear counter, LED lighting, things like that. So I enjoy Nemo's work quite a bit. It is very interesting. Now Nemo also had a installation exhibition at the what was it? This installation at the Monterey Bay Aquarium. He made these sea creatures out of found objects, old irons, things like that. And he created these, looks like, an aquarium, but they're all just mechanized creatures. Old handles off of candelabras used as tentacles to make these underwater creatures. Fiber optic lighting. An old horn made to look like another type of a squid animal caught in a fishing net. And then this octopus. I think these are 2 sink drains. Now obviously he manipulates and bends them and adds things to them. But for the most part, they are as here found. So, that is movement in art, and believe it or not, that is the last principle of design.